Nambila, and this presentation is for my advanced geospatial analysis class. And this project is the last project that we needed to turn in for the end of the semester. So, the area I pick for this final project is New York City, and the tool I use is ArcGIS Pro, and the data set I found was the Airbnb data set that I found on Kaggle. And so for this project, there's three different analysis technique that I use on this data set. The first one was really simple. It was just a buffer that create around a point of interest, trying to find Airbnbs that were 5 miles away, those particular point of interest. The second case is point density. So I aggregate all my data and was trying to find which part of New York City was the most expensive. And lastly, I use optimized hotspot analysis. So now that we know all the different use cases that are used for these projects, let's go over them and how I use ArcGIS Pro. So for case one, what I did is after downloading the data on Kaggle, the data was saved as a shape file, as a CSV file, and so it came under this format. So you can see there's different row, there's the ID, there's the host name, there's the neighborhood, there's the latitude, the longitude, and there's the price, and there's the number of review. And so when I was going over the data and trying to find something that'll be good for my final presentation, and I come across this particular data set, it came into my attention that there was like a longitude and a latitude and longitude column, which means that this data was spatial, and if I imported it into ArcGIS, I could convert it into point analysis for my project. And so, if we go back to my presentation, that's what I did. So after importing the data as a table, as you can see here, as a CSV file, I was able to convert it into point data. And as you can see on this image, that's how it's shown on ArcGIS Pro. But it was kind of too dense, you know. And for the specific first use cases that I wanted for this project, I was trying to find Airbnb that were 5 miles away from three point of interest, and the three point of interest that I selected was the Statue of Liberty, the Empire State Building, and Central Park. And when I was going online and I was trying to find a data set where I could find the Empire State Building, the Statue of Liberty, and Central Park, I couldn't find any. So I remember that in the class we learned that you're able to create your own feature in ArcGIS Pro, and so that's what I did. So after going back to the spatial database, I added a new feature class, and in that new feature class, I added 3 point, and so I manually added them. So what I did is I went on Google and I went to look for the geospatial location of Central Park, the Statue of Liberty, and the Empire State Building. And after finding the geospatial data, I just look into ArcGIS and enter those specific coordinates, and it kind of show me the location where those 3 point interest was located. And so I just click and added 3 point into the new class that I created. And once that was done, I was able to add all my data on top of it, the previous data. And so one of the feature that we wanted out of this data, we really wanted to kind of remove all the Airbnb that was not the entire place, you know, because the data that we get in the beginning is show like Airbnb where you can rent the entire house or just rent one bedroom, or like you had to share the space, and we didn't want that. And so we filtered the data. And so what I did, there's multiple way to do it, but the way in particular I did it is I went into the data set and I selected by attribute, and I only selected the one where you can uh, rent the entire Airbnb, and then I selected them and import as a new shape file. So that's why on the side you can see that's like my layer with all the data, and this one is the layer with only the entire Airbnb. And so after importing the new layer, I unclick that one, and that's the one that's showing on the map. And so after that, we wanted Airbnb that was only 5 miles away from those 3 point of interest that we previously created. So what we did is we created a buffer, a 5 miles buffer around each point of interest. And so what I didn't want to happen is sometimes if there's an Airbnb that was like perfectly 5 miles between two buffer, it wouldn't count. So what I did is I dissolved the buffer, so that's why they're showing up like that. So I dissolve all the buffer, and it created kind of this feature I can see, which intersect other feature on the map. And after that, I used the clipping tool to remove all the Airbnb that was not within that distance. And so after running that tool, that was my outcome. And as you can see, I also changed the symbology because I wanted it to be a little more clean. And that's kind of what allows us to have this result. And so, in conclusion, for this first use case, we can see that by creating your own feature and having all the existing data, you can do some really nice analysis, especially building a buffer around tool that you manually created yourself. You're able to do some pretty amazing thing. And the clipping tool kind of make it really nice at the end, really want only the data falling under the buffer that you created. So, for my second use case, I was trying to understand which part of New York City between Brooklyn, Queens, the Bronx, and Staten Island and Manhattan was the most expensive one. And in order for me to do that, I needed to go online where I found a shapefile where I could find all those areas that I was interested in too. And so after downloading the shapefile, I uploaded into my ArcGIS. And after uploading into my ArcGIS, that's what I got. But I thought that I could go a little bit further. So after opening the the table of content, and I will show what I did. So if we go back here on ArcGIS, so after opening these table of content, this attribute table, is going to load for a bit. So after opening this attribute table, we can see that in borrow name, all those polygons are categorized by either belonging to Manhattan or belonging to a different part of New York. And so it's that attribute that I use for the following step of my project. And so, because I knew that each of those polygons were either categorized as Manhattan or Staten Island or the Bronx, I used a geo processing tool that allow you to divide by attribute. And after my tool divided all my polygon by attribute, that's the result I got. And in order for each tool to kind of stand on its own a little bit, I kind of color coded them a little bit different. And you can see now they each stand out and they don't not just have the same symbology. And so when I was there, I was now able to kind of use all the previous point that I created. So I added them back to my map as a layer, and you can see how it's really distributed. And I make sure I change the symbology so it kind of doesn't obstruct too much the base map. So we can see how kind of the Airbnb distribution is around town. And so after that, I decided to use another geospatial tool to create it to kind of create a heat map to see how the Airbnb distribution was across New York City. And so after using that geospatial tool, that's the map that was produced. But as you can see, it's kind of hard to tell because when I use that tool, it created 10 different classes. So it doesn't really emphasize much which area. So what I did, I went back into my symbology, and instead of having 10 classes, I changed it to 5 classes to make it more more easy to understand and kind of see trend pattern. And so after changing to um, 5 classes, we can see that there's a darker shade of purple in Manhattan. And so we came to the conclusion that between all the different side of New York City, the ones that's the most expensive Airbnb is Manhattan. And especially, we made that conclusion because when we run the tool, the characteristic, the attribute that we selected to run this analysis was the Airbnb price. So we can see that it's really aggregate. But it was a pretty easy conclusion to make, you know. We thought with the help of the tool, it was an easy visual conclusion to make. But I thought that I could go further into analysis. And so that's why I added back my 3 point that I previously created in part one to this map. And after adding that, I came up to another conclusion. So on this map, for example, we can see that the Empire State Building and Central Park are both located in Manhattan. We make it a really, really desirable location for either businesses, local tourists, or anyone going to New York City. And coming to that realization, it makes sense why the Airbnb in this location would be more expensive compared to other areas. And as I concluded my case too, I also came to the conclusion that um, it's true that the Airbnb price is set by the Airbnb owner, but also what is around the area, the neighborhood, the urban lifestyle, everything around the area play a big factor in determining the price of the Airbnb. Because if you may put an Airbnb that's below the cost of the average Airbnb in Manhattan, you be the one losing money. So it kind of makes sense that everyone would kind of price it the same way. And so that was the conclusion that I came from my case two. And so for my case three, I thought about something different. You know, in case one, I wanted to see which Airbnb was within a 5 mile radius from my point of interest. From case two, I wanted to see which part of New York had the most expensive Airbnb. But for case three, I wanted to do something different. I thought that what if I mix the two methodology to create something new? And so that's what I did. And so in this case, I create a spatial join between the shapefile that I downloaded from the shapefile that I downloaded about New York, the Bronx, Staten Island, and Manhattan, and the original Airbnb data that I had at the beginning. And so after doing that, I would just show in ArcGIS. After doing that, I came up with these NYC spatial join. And when you open the attribute table for this particular data set, it's going to take a while. There we go. That you can see that the polygon show that the location of each, but also it showed the Airbnb location that we saw at the beginning with the original CSV dataset. So this layer in particular is a shapefile with the data that we want at the beginning, which is perfect for the analysis. And so if we go back to the presentation for case three, so that's what I did. And so after having this shapefile, we use the hotspot, the optimized hotspot analysis geospatial tool, and it was a quite lengthy process. It took about an hour for the calculation to finish, but I was really happy with the outcome, and that's what I expected. And so from these spatial joint file that we fed into optimized hotspot analysis, it created this map. So you can see hotspot from red to blue. So from hotspot with 99% confidence and cold spot with 99% confidence. And so when I saw this result, at the beginning I was a little bit confused because I expected Manhattan to be the spot, being the hotspot, because it's the most likely location. There's the Empire State Building, this Central Park. I thought Manhattan area of New York would be the area being the hotspot, and all the other location would be like the cold spot because they're kind of a little bit like farther away from what's happening. But then, after really thinking about it and doing some other analysis, I came up to another conclusion. I realized that these results actually make really sense, so much sense, because right, as we saw on case two, Manhattan is the location that's the most expensive Airbnb. So therefore, people are more likely to go pick other area that are less expensive, but that's still in New York. And so that's the reason why Manhattan is actually a cold spot, because not many people go there, and instead they pick a more affordable option in part like the Bronx or Staten Island. And that's the reason why the map came out this way. And so, if we even go back into hotspot analysis, we can see all those different G value and shape area, and we understand why it is that. And by running this specific geospatial analysis for my case three, I came up to a really interesting conclusion, and it told me a lot about the process of decision making. In the first place, you will assume that the most popular place with the highest attraction will be the one attracting the more people. But as you can see after this analysis, we can see it's not the case. We can see that it's actually quite the opposite, because this area is so popular and everyone want to go there. That's the area people try to involve, and that's what make it turn into a cold spot, and people turn into a more affordable option. And so, in conclusion, before we close, we're going to go quickly into ArcGIS to show all the different layers that we use for this lab, from the beginning to the end, and the hotspot analysis, and even the histogram per month. Um, there we go. It's going to load. And even the histogram that we produce, uh, even is just taking a little bit to load. And even throughout the histogram, you could understand all the trends and pattern that was explained that I previously mentioned. And if we go back, there we go, that we can see the histogram here, the median, the mean, the median, and the standard deviation. And so, and so now that we're back into the graph, in conclusion, in conclusion, GIS is a really interesting tool. It helps us really understand the trend and pattern of a data set, and really see what's happening and come up to conclusion through case one, case two, and case three. We will assume that they a different workflow, but the way I designed this project is each workflow fit into the other one. So, for example, what we created in case one fit into case two, and what we created in case two fit into case three. It show you how GIS as a tool kind of help you understand your data set better, see trend, see pattern, and even create your own data that you can couple or mix or join with all the existing data to have a deep analysis. So this was my final presentation for the semester for advanced geospatial analysis. Thank you.